Hello, in this video I'm going to be demonstrating how to do game 1 from Prep Test 42. Okay, so this game involves subcategories of players or subsets of players. So basically it is an in and out game. Okay, so we might also call this a selection game. Out or selection. So essentially it means that all of our players will either be selected, so in the in group, or in the out group. So there are really only two groups. But this is primarily a grouping game. It just also involves subsets of players. So here we have 5 players in, and we have a total of 9 players, so that means that 4 will be out. Okay, so that's our basic in and out setup. And then I'm going to list my players, but I'm going to do something that's maybe a little unusual, but I do find that it's been the most effective technique for me. So for my different categories of players, I'm actually going to just switch up my writing style here. So for the first set, capital letters, for the second, lowercase letters, and then for the final set, I like to do cursive. Okay, so you can choose whatever indicator you'd like, but I do find that it's helpful for me to just make them visually distinct. I do find that helps me keep track of which players are sort of grouped together, if that makes sense. Okay, so we do need to have at least one of each type. So a minimum of 1 of each are selected, right? So we have a minimum of 1 of each. Okay, our first rule is that if we have more than 1 botanist, so that's B, so if we have 2 botanists or 3 botanists, right? So if we have 2B or 3B, then we have a maximum of 1 zoologist. Now, if we have a minimum of 1 and a maximum of 1, that means we have exactly 1 zoologist. All right. If we have more than 1 zoologist, so 2 or 3 zoologists, then we can't have 2 botanists and we cannot have 3 botanists, which means that we have exactly 1 botanist. Once again, we have a minimum of 1 botanist from the original setup. Okay, so there's our contrapositive. Rule 2 tells us that F and K cannot both be selected. So if F is selected, then K is not. If K is selected, then F is not. Rule 3 is with K and M. So if K is selected, M is not selected. If M is selected, then K is not selected. And then our final rule, rule 4, is if M is selected, then both P and R must be selected. So if P is not selected or R is not selected, then either of those would trigger M to also not be selected. Okay. So yeah, I mean we do know that we have quite a few limitations here, right? So it's going to be really easy to fill up this pool of players that are out. And as soon as we fill up this pool, we know that every other player is going to be in. We can, try to identify some wild cards, some sort of free agents or floaters, players that are less restricted. But I think primarily this game is going to be about checking to see if any of these rules have been triggered, and then making sure we follow through with the consequences. Okay, so I'll go ahead and do question 5 just to demonstrate that. Okay, so question 5 starts with a question-specific condition, which is if both G and H are among the scientists selected. So G and H are both botanists. So if we have both of them, okay, we have G and we have H. And because we have 2 botanists, that means we have exactly 1 zoologist. Okay, so we only have 1 zoologist. We know we need at least 1 chemist, and then the final position could be a chemist again, or it could be F, right, the remaining botanist. Okay. So at this point, I haven't made enough deductions. I think I likely haven't made enough deductions to actually just get the correct answer. So I'm going to go ahead and see if there's anything else that's triggered. Okay, so I know from Rule 1 that I'm only allowed to have 1 zoologist. So I would be looking for rules that deal with the zoologists, and I see that the contrapositive of Rule 4 will actually be triggered by this rule, right? So it's not possible for us to have both P and R because they're both zoologists and we can only have 1. So one of them will be out. Doesn't matter which one it is, that will mean that M is out. Okay, so we have room for 2 zoologists out, but also M will be out. Okay, now it's tempting to think that that's going to trigger Rule 3, but remember that the triggers are on the left side of the arrow, and just because M is out doesn't necessarily mean that K is in. Okay, we do have a 4th spot there, which would be occupied either by a chemist or a botanist. All right, let's see. Now, it doesn't really matter, now that M is out, or, it doesn't matter if P, R, or Q is in at this point. So I'm just going to go ahead and add P, put Q and R out. So yeah, like I said, that doesn't really matter. For chemists, if I put K in, then F is out, which means L is in. If I put L in, then I could have F or K in the remaining position. So is it possible for us to have both F and K out? So I'm testing out answer choice A there, right? Answer choice A says that we must include either F or K. So in order to test it, I'm going to see, is it possible to create a viable solution putting both F and K out? And I can see immediately that that's one position out, and F and K are not used up elsewhere, right? So at least one of them is going to have to be in. But you can see by looking at the other solutions, so that means A is the correct answer, right? But if we look at the other solutions, we're going to see that B includes M is out, C includes M is out, D also includes M, and then E includes Q, and there's no reason that we would have to have either P or Q, because we just need one zoologist, so we could easily have R and put P and Q out. Okay. Let me know if you have any questions.